Okay, I was starting to say, it's a good thing because right, if you focus, you can solve these deep problems and all, but it's a really bad thing. You ever see that movie Flubber with Robin Williams? Like, almost is. He's gets so focused on his stuff in front of class, he forgets everything going around, and he comes into his physics class and he thinks, and he starts giving this lecture about gravitating bodies and how they come together. And meanwhile, they're standing over, he's completely oblivious to the two nudes standing over. He's walked into the art classroom and talking about gravitating bodies. Oh, sorry, he's got to go to his class. Or he forgets his wedding because he's busy in the middle of his experiment. Anyway, that's what we do so much. There's great stories truly about mathematicians like that too. You ever hear the story of Archimedes? He was King Hiron, I don't know how you pronounce his name, had this crown he had made for him. And I got thinking, wait a minute, I wonder if this the guy who made this thing has cheaped out. You know, it's supposed to be a gold crown. I wonder if it's just gold plated. Archimedes, tell me whether this is actually completely gold or maybe put some inferior metal inside and just gold plated. But don't cut it. If it's real, you don't want to damage the thing. So what do you think Archimedes did? He was one of the most brilliant mathematicians of all time, actually. He's considered one of the three greatest mathematicians, he along with Newton and Gauss. Well, he flustered over this problem, and he figured out when he was sitting in the public bath, actually. He's taking his bath, and he's noticing he's buoyed up by the water. And he realized you could put this crown on a scale, and weigh it out against pure gold. And if this is really pure gold, then you could put them underwater and they'd still weigh equal, right? But this is a different metal that have a different density, and the scale will tilt, right? Because underwater, the thing will be buoyed up. It weighs the difference between its weight and the weight of the water displaced. And so it'll weigh differently underwater. And he got so excited, he ran down the street saying, Eureka, Eureka, I found it, forgetting he was naked. That's what mathematical concentration does for you. That was to wake you up. There's other great fun too. Anyway, unfortunately, that Flubber movie is really true. All right, so now we said, now we can do some other problems to solve, we said, but I did try and put a little twist on this one. I did yesterday with a little twist. To solve a times trig function plus b equals 0. What do you do if you got a trig equation like that? It's not any longer trig function equal a number, but a number times a trig function plus a number equals 0. Can you imagine what you do there? Remember? You just subtract b, divide by a to get trig function equals a number. Go to step 2 if it's a multiple angle, or go to 1 if it's not a multiple angle, right? So for instance, suppose I have this one. Solve cosecant square root 3 cosecant theta plus 2 equals 0. Suppose I have that equation. Now what you do, since it's a trig function plus b equals 0, you subtract 2 and divide by square root 3, getting equivalently cosecant of theta equals minus 2 over square root 3. Now it's trig function equals number. And there's not a multiple angle, so I go to 1. I solve this on the unit circle. The last one is not sine or cosine or tangent. What do I do? I might try the reciprocal. The reciprocal of left is sine. The reciprocal of the right is minus square root 3 over 2. So I'm really solving sine theta equals minus square root 3 over 2 is what I'm doing on this one. Now I can do it because that's right, draw the unit circle. Sine is the y coordinate. So I want the y coordinate to be minus square root of 3 over 2. It's back down here. There's exactly 2 terminal rays right there. I can figure the angles by dropping perpendiculars. I drop this one and say, well, it went from 0 down to minus square root of 3 over 2. This side must be square root of 3 over 2. So unit circle, that must be 1. This can only be a 30, 60, 90 triangle, angle pi over 3. By symmetry, this one is pi over 3. And I can figure all the angles, right? Well, here's the other twist. Solve this. Suppose I solve this for 0 less than or equal to theta less than 2 pi. Solve it within one rotation. Sometimes you don't want all angles, you just want to know what are the different directions. So solve within one rotation. So I'm going to do that on this one. And what I do here is I say, well, this angle is minus pi over 3, but that's not between 0 and pi, 2 pi. So instead I'll go this way, go all the way around to, let's see, pi plus pi over 3 is this one. And then this one all the way around here is 2 pi back up pi over 3. Right? Well, that one will be 2 pi less pi over 3. And then you have to use your quotients, right? 2 pi is 6 pi over 3. You get a common denominator. 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. That's this angle, right? 2 pi less pi over 3 is 5 pi over 3. And this one, 1 pi and 1/3 pi is 4/3 pi, right? That's that one. So the answers then are theta equals 4 pi over 3 and 5 pi over 3. But you have to make sure you start here and go around to the first one and go around to the second one until you get them all. It's usually 2 of them. And there they are within 0 to 2 pi. I don't have my plus 2k pi now since I'm just doing one rotation. All right, another example. Suppose I had to solve 3 cosine theta minus 1 equals 0. How do I solve this one? Oh, a cosine trig function plus b equals 0. I just subtract b from each side and divide by a. I write equivalently, this is method 3, cosine theta equals 1/3. Go to step 1, right, because it's a single angle trig function equal a number. We're going to do this. All right. Now, however, this does not come from a special angle, so what am I going to do? All these others have been special angles, but in real life, you don't usually get those. You're a surveyor, hardly ever will you get that lucky that it comes out a half or a square root of 3 over 2, right? I stat as surveyor, so let's see, not from a special angle. What can I do?
Often the calculator.
Say again?
Often the calculator.
Yeah, okay, so we'll use calculator. What do I put in the calculator?
What, the inverse of cos, isn't it? Or not the inverse of cos, but cos -1.
Yeah, arc cosine, yeah. So I'm going to put theta between 0 and 2 pi. Again, let's say, suppose I don't want all solutions. I just want them within one rotation. A lot of the problems are like that. What I'll do is I'll go to solve trig function equal to number. I just go to the unit circle, right? Here it is. And now I want the x coordinate to be 1/3. So I still draw it. X equals 1/3. I go 1, 2, 3 here. There's 1/3. So even if you're going to go to the calculator, you still draw this. And you say there's one spot, 1 point here, 1 point here in the unit circle where the cosine is 1/3 because the x coordinate is 1/3. That's this terminal ray, that terminal ray. What angles are these? These kind of things. This one is the one you said, right? This doesn't come from the special angle, so it's not going to be 30 or 45, but I do know there's one solution when cosine is 1/3 is always arc cosine of 1/3. And you can run it on the calculator. That's this one. How do I know it's not this one?
It's causative, isn't it?
Yeah, our cosine is always the unique angle between 0 and pi, so whichever one is in here. So it's this one, not this one. So that's this one, but that one's the arc cosine, but I also need this one because this is also included in the equation, right? What's that one? Symmetry, right? If this is arc cosine, then this must be arc cosine, right? They go the same, they drop to the same point, they must go the same angle either side, so this must also be arc cosine of 1/3 if I take it counterclockwise. Counterclockwise, it'd be minus arc cosine of 1/3. But also that's arc cosine of 1/3. So one angle is arc cosine of 1/3, this one. The other one is 2 pi back up arc cosine of 1/3. So there it is. You have to round this one because that's not an exact number. On your fancy Dan calculator, right, it will just leave the answer like this, arc cosine of 1/3. If you put it in and say, why isn't it giving me the decimal? So this is for those of you that bought that expensive calculator and then cursed me afterwards, because you can't get that. All you have to do on the TI-89 is put a decimal point on one of these. Once you do, it assumes it's a rounded number and it gives you rounded numbers thereafter. Or you can put it in approximation mode. There's a mode you can put in and do everything in decimal if you want, but who wants that when you get exact? So put arc cosine 1 divided by 3 point, or 1 point divided by 3, or 1 point divided by 3. Put a decimal on either of those numbers that will give you the decimal answer instead. Better get my. You can get it in degrees or radians. I've got this in degrees right now. Let me put it in radians. All right. And inverse cosine 1 divided by 3 point, close the parentheses, I get 0.23 something. That's your rate that didn't need. 1.23. All right, and then the other one you want here, this is 2 pi back up arc cosine. That's what that is. So on the next line, you can put 2 pi minus second ands, and it will put all the decimals you just did, save you some time, but 2 times and 5.05. So two answers between 0 and 2 pi. This many radians and this many radians. That's what you do when it's not a special angle. You just use the calculator for one and figure on the unit circle how to calculate the other one. Okay. We have the last one here was 4. If you have a times, if you take a times trig function squared plus b times trig function, same trig function, plus c equals 0. Right? What did we say we do for this one? We simply let u equal the trig function. Because then what we get is AU squared plus BU plus C equals 0, right? And it's just a quadratic equation. We know how to solve that from algebra, right? We started to mention that last time. But there's actually two ways to solve this quadratic equation. How do you solve? There's three technically, but two major ways. Solve either by what?
Factoring.
Yeah, either by factoring or the quadratic formula. Don't know it now, you will need it for the test next week, because this might be on there. And it's u or x or whatever the variable is. It's minus b plus or minus square root b squared minus 4ac all over 2a. Expect you to have this one memorized for the test, actually. Then this tells you what u is, right? Then this is trig function equal these two numbers, one for the plus and one for the minus. Now you go to steps 1, 2, or 3. Actually, it's a 1 or 2 because this will be 2, depending on what kind of which case. But it gets you trig function equal a number. Yeah, so that's how you solve a quadratic equation. Start to get very tricky. That's why I said this is one of the harder sections of the semester. That's why we're spending a little extra time. Bring me some questions tomorrow too, and we'll do some more. But here's I said solve for values on the interval for the 2 pi. Round to 2 decimal places. And I give you this one. Tangent squared, I'm going to change x to theta in here. Tangent squared plus theta plus 3 tangent theta. I like to do that because then I use x for the unit circle. Minus 3 equals 0. How about that one? Well, when you see quadratic equation in a trig function, because you see a square of a trig function, you immediately substitute u equal a trig function, right? U equals tangent theta. This one then gives you tangent squared means tangent of theta squared or u squared plus 3u minus 3 equals 0. Well, this is a pretty difficult one to factor. If you try factoring this one, you'd have a hard time. The other way you can do it is you can complete the square, but that's equivalent to the quadratic formula and takes longer, so we won't do that. This one is hard by factoring because if you calculate A, B, and C, you might do this before you start. B squared minus 4AC is equal to what? 3 squared minus 4 times 1 times minus 3 is 9 plus 12 is 21. When that's not a square, it's really hard to factor it. I teach you a little bit of algebra here, even though I won't ask all the algebra on the test. For your education, so you do well in later math classes. because this is not a square, I'm gonna go immediately to the quadratic form. I'm gonna say u equals minus b plus or minus square root b squared minus 4ac all over 2a, and you have to memorize that. Otherwise, you have to figure it out every time. That takes a long time. Okay, so b was 3, so it's minus 3 plus or minus square root 3 squared minus 4 times a is 1 times c is minus 3. Oh, I could have used what I already got, right? This was 21. So once you compute this, you can use it right here and save yourself some time. All over 2a, 2 times 1. So I've got minus 3 plus or minus square root 21 all over 2. Now, if you're a good algebra student, maybe you know what that tells you about factoring. How does this factor? If I factor this, u minus blank times u minus blank equals, so I factor this, right? 1u, so I put 1u on each of these. What goes on the blanks to factor this?
Opposite or
It goes, these numbers go on the blanks. U minus this number and U minus the other one. So if you could guess to put in these blanks, minus 3 plus square root 21 over 2, minus 3 minus square root 21 over 2. You could factor it by hand. This is what you have to do to factor it. Ah, right. Use the quadratic formula. It's too hard to guess that, right? So just use the quadratic formula. It tells you what would have gone in the blanks if you factor it. But that's the way it always happens. If the lead coefficient is 1 like that, then it factors as u minus blank times u minus blank, where the blanks contain the solutions of the quadratic formula. All right, so those are the solutions, but wait a minute, u was the tangent theta. All right. I'm supposed to solve this in 0 to 2 pi. So what I do is now I've got it, trig function equal a number. There's actually 2 cases. I break it into 2 cases. I got tangent theta equals minus 3 plus square root 21 over 2, or tangent theta equals minus 3 minus square root 21 over 2. It's always going to get hard in this section, right? And now that it's trig function equal a number, I solve it on the unit circle. Go to method 1. Right? There's not a multiple angle, so I don't have to go to 2. I just go to 1. What in the world? Square root of 21, if you think about it, square root of 16 is 4. So this is minus 3, and square root of 25 is 5. So this is a number between 4 and 5. Minus 3 plus a number between 4 and 5 over 2. This will be a positive number, right? This is 4 point something, right? Between 4 and 5. So this is going to be a positive number. I'll draw it over here. And I say this because what you want to do is draw it on the right side. If you draw it on the wrong side, you can be in trouble. But here is a line. Oops, not that one. I'm sorry. It's a positive angle. Let's say it that way. Something like that. And what the ratio of y to x could be this number. And so what's this angle here? I'm saying since this is a positive number, I'll draw it, the tangent is positive, and I'll draw it in the first quadrant here. And we'll say this is then the arctangent of minus 3 plus square root 21 over 4. Because this is a positive number and arctangent is between plus or minus pi, the arctangent of a positive number is always in the first quadrant. Arctangent of a negative number is always in the second quadrant, because arctangent gives you a number in here, first or fourth quadrant. Arctangent of positive up here, arctangent negative down here. So this one being positive will be in the first quadrant. And this is one solution. One solution to tangent theta equals a number is theta equals the arctangent. But what is the other solution? Remember, for tangent and for tangent cotangent, the opposite solution is always the opposite direction. So what you do is go the opposite direction, say this is also arctangent 3 plus square root 21 over 4. And there's 2 solutions, arctangent and arctangent plus pi. I need to erase this. So you have theta equals arctangent 3 plus square root 21 over 4. Wait a minute, 4, it should be 2, right? This is 2, I don't know why I wrote 4. Or that plus pi. You have to draw this, if it was in the fourth quadrant, then you have to add pi, or only between 0 and 2 pi. So if you get a negative angle, you have to add pi to it. Anyway, so the other answer is arctangent 3 plus square root 21 over 2 plus pi. That's this one. Now we're half done, right? In some sense we are. We didn't do this one yet. Those are the solutions to this one. Now we come over and look at the other one. And if you think about it, this is a negative number, right? -3 minus something between 4 and 5 is negative. So the whole thing is negative. This is going to go in quadrant 4. You want the ratio of y to x in quadrant 4 to be this negative number somewhere way down here. And we have this one is arctangent of -3 minus square root 21 over 2. But that's not a solution. Why not? It's negative, right? If I take tangent of a negative angle, I'll get something in the fourth quadrant. And what I want is answers between 0 and 2 pi. So my answer is not that one. It's these two angles. One of the opposite angle also has the same tangent. I mean, this one has the correct tangent, but it's not between 0 and 2 pi. So what the angles you want are this one, which is pi back up by this amount. And this one, 2 pi back up by this amount. So it really helps to visualize this if you're visually oriented on these. Right? So here's the other two solutions. Arctangent -3 minus square root 21 all over 2 pi minus that. Gives you this one. And 2 pi minus arctangent -3 minus square root 21 over 2. Those are the exact answers. If you put a decimal point on any of these numbers, you can use your calculator to get decimal answers. And then round to 2 decimal places. What the problem's asking for. We could do one of these just to check if we're getting the right answer in the back. I'm pretty sure that's right in the back. So check your answers when you're done. Let's try this one just to see what we get. But see, once you have this one, you just push plus pi and it carries pi lots of digits, so you can get that one real accurately too. It's easy to make a mistake on these two. All right, again, make sure on the calculator have parentheses around here or a long bar underneath so it does the addition before the division. It's a good practice, calculator practice on this one. Arctangent. And you also want to make sure it's in radians mode. There's so many things that go wrong in this. Arctangent 3 plus 21 close. I'm going to put all that in parentheses. All divided by 2. Parentheses. And that gives me, it regurgitates what I did. So if I multiply that times 1 point, convert it to decimal. Whenever you do this and you forget to put a decimal point on, when you get the answer, just put times 1 point on this expensive calculator will convert it. As soon as you're multiplying by a rounded number, it converts it to decimal. So I got 1.3, 1.31. Then if you add pi plus pi, I get 4.45. So hopefully that looks like what's in the back end. et cetera. You have to do those two in the calculator too. All right. Supposed to save this for Thursday to do this kind of thing. That's what they always do. They always lay off the employees on the last day of the week, so they go home and fume over the weekend and get over it and come back and find something. And we did that when we got rid of the cross-country team here, which we gave them all their notice right before the Christmas break, and so they didn't get they got to fume all over Christmas break and then come back and weren't quite so mad. It was terrible. But we had a 100-year-old cross-country player in this dump picture. Wanted to put in the Major League Soccer out here. It couldn't fit the soccer field inside the track. And so then soccer didn't go, so we just didn't have a cross-country team. Or track, well, men's. Anyway, some of the track and cross-country went, at least. Don't know in the women's. Okay. Any questions on all of that? I should have saved this for tomorrow. I'm not in a bad mood tomorrow, I understand. All right, so let's do a little easier one here. Then I'm going to say finally the last one is for mixed trig functions. Sometimes you'll have more than one trig function in it, right? You simply convert to one trig function. And there's tricky ways to do this. And some of these I'm just going to have to be careful about. Like, for instance, here's 7a. This assumes a couple of things out of the sections we haven't done yet. But in 7a, it says sine squared x minus cosine squared x minus sine x equals 0. How do I solve this one when it's got both sine and cosine in it? Oh, right? Here's the grand oompa of all the problems, maybe. What you do is you say, wait a minute, cosine of x is 1 minus sine squared by the Pythagorean identity, right? Now it's all in sine, and then you go back. So for mixed trig functions, use a trig identity. So if, for example, by trig identity, to convert it to have only one, and then go to method 4, 3, 2, or 1. Go to previous method. So that'll be it. This will be sine squared x minus 1 minus sine squared x minus sine x equals 0. Right? So it's 2 sine squared x minus sine x minus 1 equals 0. What's that? That's the check vote, right? Go to method 4, right? It's a quadratic quadratic equation, the trig function. So go to 4, method 4, and it says let u equal the trig function you see once you have one trig function, sine x. There are a couple of these for which this strategy doesn't work, but I might mention those next week. If I write that in terms of u is now 2u squared minus u minus 1 equals 0, right? So it's replacing sine with u. And this is a quadratic equation. This one I might be able to factor, right? Let's try factoring. Ever had a factor? I want blank u plus blank u plus blank in here to factor this. And what I want here is, remember, the product of these has to be the lead coefficient. So the product here is 2. And the product here has to be minus 1. This number, right? The product of these has to be the lead coefficient. The product of these has to be the constant term. So what can I put in here? I can try 2 and 1. So these multiply to 2. And then this must be 1 and minus 1 or minus 1 and 1. Well, if I put it this way, I've got 2u squared plus 2u minus u is plus u. That's wrong. So it must be the 1 goes here and the minus 1 goes here. I'll write this a little better. It's 2u plus 1 times u minus 1 equals 0. This is the way it factors. You just FOIL it to check, right? FOIL says 2u squared minus 2u plus u, right? First, outside, inside, last is FOIL. So 2u squared minus 2u plus u minus 1. And sure enough, 2u squared minus u minus 1. That's the way it factors. Now what you get from this is either 2u plus 1 equals 0, right? The zero product property. If you've got this factored equal to 0, then either this is 0 or this is 0 to make the product 0. Either 2u plus 1 equals 0 or u minus 1 equals 0. There it is. Now I've got it, right? Go to method 2. This is 2 sine theta plus 1 equals, not sine, yeah, sine theta plus 1 equals 0, or sine theta minus 1 equals 0. Method 2, I'm sorry, 3. A trig function plus b equals 0. You subtract b and divide by a, you got sine theta equals minus a half, or sine theta equals minus 1. Cut this off here. You just subtract b and divide by a. Now you got trig function equals number. You go to method 1 and solve it on the unit circle. I'm out of time, so I need to quit here, but this is the y coordinate on both these circles. So you have on this one, y equals minus a half right here, and 2 angles. Looks like theta equals 7 pi over 6 here, 11 pi over 6 here. I'll just write the answer real quick. This one, you got the y coordinate equal minus 1. Right, y equal minus 1. This is y equal minus a half. This one just touches at the bottom, and this one is theta equals 3 pi over 2, right? 1 pi over 2, 2 pi over 2, 3 pi over 2. Anyway, so those are the final answers. I skipped a little at the end, but some of these you have a lot of steps. So try all the problems out of there except let's do 7.5, 1 to 6 over the break. Don't do these for tomorrow, pay for the quiz. All right, and
Good day.
thank you, Jim. Yes. Okay.
So it's, 1 plus tan squared. So I wasn't here for this lesson, so I just need a bit of guidance on.
Oh, yeah, we didn't do this. That's the trouble. We
We
didn't actually.
didn't actually do. this.
Yeah, you didn't miss anything. I skipped over 7.1.
Okay.
That's what I was trying to say at the beginning of class. We did 6.1 to 6.3, and then we skipped to 7.5. We'll come back and do that. That's why it's so hard, yeah.
Okay, yeah, I mean, I get the gist. I did A through C.
Well, good for you, yeah.
But D and E are pretty.
Yeah.
More complicated, so.
Yeah, we'll come back and get that, maybe a little tomorrow, but probably I'll wait till after the break, because I hate to do it tomorrow and then everybody comes back forgetting it all.
They're in the textbook, aren't they?
Yeah, yeah, everything's in there, yeah.
Because I couldn't find any examples online whatsoever on these. It kept showing, it would show ones like these with an equal sign, right? And there's another side of the problem, but there was none set up like that, simplifying the equations. It was always just solving.
On 7.1?
On 7.1, the type that, it was always solving, not simplifying, so.
Every trig book has that. If you want, you can borrow one from my office, maybe I can find a spot for you to look at. You're welcome to. I just get those for free once in a while. maybe I can find a spot for you if you want, look at what they do. Otherwise, yeah, our textbook certainly has it, yeah.
All right, I'll take a look. Thank you.
Okay. Yeah, we won't get to it till next week much.